Hello and Assalamu alaikum. Today we have here Cambridge IGCSE Chemistry Paper 4 Theory version extended. Theory extended Paper 4 to February March 2022. Total time for which is 1 hour 15 minutes and total marks 80. So question 1. This question is about the first 30 elements in the periodic table. Name the element which is 78% of clean dry air. So this is factual information. You just have to remember this. Nitrogen consists of 78%. The air consists of 78% nitrogen, 0.04% carbon dioxide, 1% noble gases, and the remaining oxygen. So 27% approximately oxygen. So, sorry, 21% oxygen. Has atoms, name the element which has atoms with an electronic structure of 281. So it is evident that one electron is present in the outer shell, which means that it is from group 1. So, and it has 11 electrons. So if we look at the periodic table, it has 11 electrons. 11 electrons are present in sodium. So the correct answer is sodium. Forms an oxide with a giant covalent structure. So we have three giant covalent structures: silicon dioxide, silicon oxide, we have um, graphite, we have diamond. So the only oxide is silicon oxide. So we have the element which forms the oxide is silicon. So the correct answer is silicon. Is the gas with the slowest rate of diffusion at room temperature. So the slowest rate of diffusion means it should have the highest MR, as the rate of diffusion is inversely proportional to MR, the rate of diffusion. So the slowest rate of diffusion means the highest MR. So that will be, if you look at the periodic table, the highest MR is, and of the first 30 elements. So we have chlorine, 35.5. 35.5, and it exists as two atoms, so it will be 35.5 times 2, which will be 72, 71. Has an anhydrous chloride which turns pink when water is added. So the test for water is cobalt to chloride and copper to sulfate. So when water is added into anhydrous cobalt to chloride, it turns from blue to pink, and copper sulfate turns from white to blue. So this is cobalt to chloride, but we have to write the answer is cobalt because the chloride is formed by the cobalt. Next has aqueous ions which form a white precipitate when added to aqueous silver ions. So the silver has insoluble salt with Cl. AgCl is an insoluble salt which will give us white precipitate. When Cl reacts with Ag, it forms AgCl. So C chlorine is the answer again, because the chlorine ions, when they react with Ag plus, they formed AgCl solid. This is aqueous and this is also aqueous. Forms a blue hydroxide which dissolves in aqueous ammonia. So the test for cations, the blue hydroxide means that when you add NaOH, blue PPT is formed, or yeah. So, and it dissolves in aqueous ammonia. So this is copper. So the correct answer is copper over here, because the colored compounds of copper are blue and it also dissolves in ammonia. Next is added to molten iron to remove impurities in the steel making process. So this is also factual information. It's just oxygen is used to galvanize iron. So galvanization is when we add a metal layer to protect the inner metal from being rusted. So this is zinc, as zinc is higher in reactivity series. So zinc reacts first with the oxygen and it forms a sacrificial protection layer. This is It forms a protective layer and this is called sacrificial protection. So the next question is a student adds excess large pieces of magnesium carbonate to dilute HCl and measures the volume of carbon dioxide given off. Add the missing state symbols to the chemical equations for the reaction. So we know all carbonates are insoluble except for sodium, potassium, and ammonium. So this should be solid. All acids are aqueous, and water is obviously liquid. Carbon dioxide is gas. They've told us over here. Complete the dot and cross diagram to show the electron arrangement of the ions in magnesium chloride. The inner shells have been drawn. Give the charges on the ions. So magnesium is in group 2, so it will have a charge of 2 plus. Chlorine is in group 7, so it will have a charge of minus 1 because it needs to gain 1 electron. Now, furthermore, what will happen is that magnesium will have another shell. It originally has 3 shells, but in the last shell, it has only 2 electrons, which have been donated and donated to each of the Cl ions. One Cl, each Cl took 1 electron from the magnesium. So magnesium gave out 2 electrons, electron 1, electron 2, and each Cl takes 1 electron. So this takes 1 electron, and this takes 1 electron, each having a charge of minus 1. So So the magnesium has 8 outer shell electrons, the magnesium ion, and it has given 2 electrons to the chlorine and 1 to each. So here we have drawn the shell of magnesium. So magnesium and chlorine both are in period 3. So they have a total 3 shells in their atoms. So this is a magnesium ion. It originally had this one other shell which had 2 electrons. Now one goes over here and the other goes over here, but not in this shell. The chlorine has one shell remaining. So chlorine is in group 7, so it should have 7 outer shell electrons originally. So if we make the 7 outer shell electrons, 1, 2, 3, 4, 5, 6, and 7. So this will be the same for this chlorine. And now we draw the electrons which it gained from magnesium. So magnesium gave 1 electron over here and 1 electron over here. So the charge thus minus 1 on each chlorine. And we have the thing which we should check at the last is that both have 8 outer shell electrons. 2, 4, 6, 8, 2, 4, 6, 8. And each chlorine should have 1 electron of magnesium. So next, oh, we have another dot and cross over here. Complete the dot and cross diagram to show the electron arrangement in a molecule of carbon dioxide. So carbon dioxide bonds like this because carbon is in group 4, so it needs to share 4 electrons and meaning 2 pairs. It needs to share 2 electron pairs. So 2 over here and 2 over here. Each oxygen, as oxygen is in group 6, so each oxygen needs also a double bond. So two double bonds, which means that the electrons are like this. So we can draw it over here like this. Now it's our choice what we give. Uh, if we select cross for oxygen or dot. But the thing to remember is that oxygen is in group 6, so it will have 6 total outer shell electrons originally. So 2 are shared over here. There will be two more like this, 2, 4, 2, 4, As carbon is in group 4, so it only had four outer shell electrons, which it shared with the both oxygens, with both of the oxygens. So these are two carbon atoms, electrons. These are two carbon electrons. So hence you have one mark for the lone pair also. So be careful with that, and the double bond also. Okay, so the graph shows how the volume of carbon dioxide gas changes with time. Describe how the graph shows that the rate of this reaction decreases as the time increases. So the rate of reaction is the volume produced over time, which will be the gradient of the graph. It is expressed by the gradient. So the gradient, as you can see, it is steep over here, but then it is decreasing. So as the gradient is decreasing, gradient decreases. So the rate of reaction, this way the graph shows that the rate of reaction is decreasing. Next, explain in terms of particles why the rate of this reaction decreases as time increases. So the rate of reaction depends upon the effective and successful collisions of the particle, how much the particles are being collided, what is the frequency, and the reason why. Because they said explain, which means you have to give a reason why the rate of reaction decreases. So what happens is as the reaction progresses, so the concentration of the reactants it decreases. So there are fewer particles which are left to collide. So the concentration, there are fewer collisions between particles as the concentration of the particles decreases as the reaction progresses. Next, the student repeats the experiment using powdered MgCO3 instead of large pieces. So there will be a large surface area, so higher rate of reaction because powdered will increases the surface area. All other conditions stay the same on the grid. Draw the line expected when powdered MgCO3 is used instead of large pieces. So there will be two marks, one for the gradient and one for where you level the line off, which means the horizontal. So the volume is not changing of the reactants, so the volume of the products will also be the same, just the size is decreasing and the surface area is increasing. So what happens is the rate of reaction will increase, and we just decided that the rate of reaction is shown by the gradient. So we will have a steeper graph, but it will level off on the same place at the same volume. So after this volume, there will be no increase in gradient, but we will reach over here faster. Next, determine the volume of carbon dioxide gas given off when excess magnesium carbonate is added to 25 cm cube of 0.4 mole per dm cube HCl at room temperature and pressure. Use the following steps. Calculate the number of moles of HCl in 25 cm cube of 0.4 mole per dm cube of acid. So the formula moles equals to concentration times volume. Mole equals to, and volume should be in dm cube. So concentration is 0.4 times 25 over 1000 will be 0.025. So the answer will be 0.4 times 0.025, which is 0.01. 0.01. Next, determine the number of moles of carbon dioxide gas given off. So the mole ratio is 2 is to 1. HCl to carbon dioxide is 2 is to 1, which means that the number of HCl moles will be divided by 2, or maybe we can do it directly. We should do it like this, X, because this is carbon dioxide and this is HCl. So X will be 0.01 times 1 over 2, which will be basically 0.005. Next, calculate the volume of carbon dioxide given off in cm cube. So just multiply this Okay, let me take it from the basics. The mole equals to volume in dm cube over 24 dm cube because every gas occupies 24 dm cube in every 1 mole of every gas. Hear me out. 1 mole of every gas occupies 24 dm cube. So the moles we know 0.005 equals to volume over 24. So the 24 will be multiplied over here. Now the volume will be 0.005. This will be 0.12. But this is in dm cube. For cm cube, we have to multiply by the 1000. So which will be 120 cm cube. Next, nitrogen dioxide is an atmospheric pollutant and is formed in car engines. Explain how nitrogen dioxide is formed in car engines. So you should know that it is formed when the oxygen and nitrogen react due to the high temperature of the engine. In the engine, there is a very high temperature due to the combustion reactions. So what happens is that the nitrogen from air and oxygen from air interact and they react to form nitrogen oxides of nitrogen. So nitrogen and oxygen from air basically react due to very high temperatures in the engine. Next, nitrogen dioxide causes respiratory problems. State one other adverse effect of nitrogen dioxide. So nitrogen dioxide basically reacts with water to form nitric acid and oxygen. So this is the acid rain, and this then causes acid rain. If you even if you leave this out, just remember this for now. Nitrogen dioxide emissions can be reduced by adding an aqueous solution of urea. Now this is not in your syllabus. This is not in your syllabus. The hydrolysis of proteins is not in your syllabus. So up till here, it is not in your syllabus. These 2 marks. State the test for ammonia. This is in your syllabus and this is mentioned in your syllabus notes for qualitative analysis. The test is litmus paper, damp litmus paper turns blue in the presence of ammonia because it is a basic gas. The ammonia formed react with nitrogen dioxide to form nitrogen and water. Balance the equation for this reaction. So we have 24 hydrogens on this side, so we should have 24 hydrogens on this side. 8 threes are 24. So now we have 8 nitrogens over here. And first, let's look at the oxygens. We have 12 oxygens over here, so we should have 6 over here. Now we have 6 nitrogens plus 8, 14 nitrogens. So on that side, we should have 14, 2, 7, 2s are 14. So this is the way it should be balanced. State how the equation shows that the nitrogen in nitrogen dioxide is reduced. Okay, so if you look at if you look over here, oxygen has an oxidation state of -2, so two oxygen atoms will have -4 and the nitrogen will have +4. Now over here it has 0. So if you look at this, it has reduced. Why? Because the oxidation state has been reduced. Or maybe you can just say that the oxygen has been lost. Both will be correct. The oxidation state has been reduced and the the oxygen has been lost. N2 loses oxygen, or previously the oxidation numbers calculation was not in your syllabus. It is added new. It is new, so you should be familiar with it because it will be frequently tested from now on. So the uh, yeah, the oxidation state of nitrogen in NO2 reduces to 0 from +4, so reduces. Next, this reaction is a redox reaction. State the meaning of redox reaction, or meaning of the term redox. So the redox reaction, re means reduction, ox means oxidation. So the reaction in which there is simultaneous reduction and oxidation. Reaction in which both oxidation and reduction occurs. 135 moles of urea is stored in the tank of a car. Calculate the mass in kg of the stored urea. So the formula moles equals to mass in grams over the mr. So we know the moles. If we multiply it by the mr, we will know the mass in grams. Then when we multiply this by 1000, we can know, oh, sorry, divide by 1000, we can know the mass in kg. So the mr will be, we have two nitrogens, so 28, because each nitrogen is 14. If you look at the periodic table, plus 4, because 2 times 2 is 4, 4 hydrogen, and each hydrogen is 1, plus 12 for carbon and 16 for oxygen. So 135 times this entire mr, 135 times 28 plus 4 plus 12 plus 16. So 8,100. The mass in grams is 8,100. If we divide this by 1000, it will be 8.1 kg. Another oxide of nitrogen formed in car engines is nitrogen monoxide. A catalytic converter removes NO by reacting it with a gas formed by incomplete combustion of the fuel. Two non-toxic gases are formed. Name the gas formed by incomplete combustion of the fuel. So we know this is carbon monoxide. Whenever hydrocarbons are burnt and the incomplete combustion takes place, carbon monoxide is produced instead of carbon dioxide, which is a poisonous gas, and NO is reacted with. This is the reaction which happens. So this way the nitrogen is reduced. Next, name the two non-toxic gases formed. So dioxide, this is the reaction, I wrote it for you, carbon dioxide and nitrogen. This is what they said, that when the incomplete combustion takes place, two non-toxic gases are formed. No, no, no. Let me go through it again. Oxide of nitrogen, nitrogen monoxide is formed. We reacted with a gas which is formed by incomplete combustion of the fuel. Because the fuel is an organic compound, whenever organic compounds undergo incomplete combustion, a gas named carbon monoxide is produced, and NO is reacted with this gas to form these two products which are not toxic. So this was the case. Next question. This question is about, again, this is also not in your syllabus, no longer in your syllabus. This is simple cell, which is not in your syllabus now. Fuel cells are used to generate electricity. Name the reactants in a fuel cell. So the fuel cell is in your syllabus, in fact. So the substances are hydrogen and oxygen. The waste product is water, which is why this is a renewable process and it is very eco-friendly. You don't need to go into much detail, just the advantages and disadvantages of the fuel cell, and that hydrogen and oxygen are the reactants, and the water is the only waste product. Next, electricity can be used to break down aqueous or molten ionic compounds. We know what this is. This is electrolysis. Name the process. Okay, so they're asking this. Name the process which uses electricity to break down aqueous or molten ionic compounds. Explain why the ionic compound needs to be aqueous or molten. Because if it is not aqueous or molten, it won't conduct electricity. And why wouldn't it conduct electricity? Because it won't have because it won't have mobile ions which can move. So because in aqueous or molten state, it conducts electricity. This is a very frequently occurring question. Why do ionic compounds conduct electricity when they're solid, when they're aqueous or molten, and why do they not conduct electricity when they're in solid form? So it conducts electricity uh, due to mobile ions, not electrons, ions. Mobile electrons are in metals. Brine is concentrated aqueous sodium chloride. Name the three substances which are manufactured by passing electricity through brine. So we have the cations Na plus, H plus, the anions OH minus and Cl minus. So what will happen is that we know that Na plus never discharges, so Na plus won't be produced. Hydrogen will discharge because hydrogen is way down below Na in the reactivity series, so hydrogen is produced. Next, OH minus won't discharge. Originally, according to the reactivity series, OH minus is supposed to be discharged, but because the brine is concentrated, so sodium chloride, so whenever concentrated is mentioned, we prefer chlorine. So chlorine will be formed. This is a rule basically, and chlorine discharges of always. Next, what will happen is that the Na won't discharge and the OH won't discharge. So the only thing which will remain in the electrolyte solution will be Na plus and OH minus. When the entire water, when most of the cations and anions have been discharged, so they will react, NaOH will be formed, sodium hydroxide. Name a different substance formed when molten sodium chloride is used instead of concentrated aqueous sodium chloride. So what happened with aqueous was that we had an interference of H plus and OH minus ions, but now when it is in molten state, it is just molten means we have melted it. So no other ions are present, only Na plus and Cl minus. So we have already written Cl over here, so we will write Na sodium metal. Next question. This question is about alkanes and alkenes. Short chain alkanes and alkenes can be formed from long chain alkanes in a chemical reaction. Name the type of chemical reaction which forms short chain alkanes and alkenes from long chain alkanes. So we know to break long chain alkanes because the shorter ones burn better and are more in demand in the automobile industry. We crack the hydrocarbons, and this cracking of the hydrocarbons is a source for hydrogen in the Haber's process also, the manufacture of ammonia. Next, decane has 10 carbon atoms. It forms ethane and ethene as the only products in this type of chemical reaction. Write the chemical equation for this reaction. So C10, the general formula is CnH2n plus 2. So C10H22, what they're telling us is C2H4 as ethene and C2H6 as ethane. Now the thing is that the overall number of carbon atoms and hydrogen atoms should be equal on both sides, meaning the equation should be balanced. So if there are 10 carbon on over this side, there should be a total of 10 carbons on this side also. So what we'll do is if we make it, we write 8 over here, now we have 16 over here and 2, we want 2 more and we write 2 over here. So what happens is, but we have to look at the hydrogens also. So let's just confirm this. 8 2s are 16, 16 plus now 2 2s are 4. So we have, oh no, we wanted 10 carbons, sorry, my bad, we didn't want 20, we wanted 10. So if we let it stay however like it is, we write 4 over here. This is now 8 carbons and 2 with this, so 10 carbons total. Correct. Now we look over hydrogen. So hydrogens we have 22 over here. Now on this side we have 4 4s are 16 and 6. So total of 22. So a little bit of trial and error will solve the question. Ethane reacts with chlorine at room temperature to form chloroethane and one other product. So what happens is this was initially C2H6. Now one H has gone and the ethane was reacting with Cl2. One chlorine came over here and the other chlorine remained as it is. So the H reacted with that and HCl hydrochloric acid is formed. State the condition needed for this reaction to take place. This is a photochemical reaction, so we require UV rays, ultraviolet light. What it provides activation energy. Ethene reacts with chlorine at room temperature to form dichloroethane. State why this is an addition reaction. So addition reaction is because no other product is formed. Only one product is formed because only one product is formed. In condensation, when esterification takes place, water is also formed. So that is condensation, polymerization, or esterification. Next, the chemical equation for this reaction can be represented as shown. The energy change for the reaction is minus 180. Use the bond energies in the table to calculate the bond energy of a carbon chlorine bond in kilojoules per mole. They've given us the bond energies, and we have to eventually calculate the bond energy for carbon and chlorine. So use the following steps. Calculate the energy needed to break bonds. So the bonds will be broken over on this side. So we have one carbon carbon double bond, so 610 plus four carbon hydrogen bonds. So four, and the energy of the carbon hydrogen bonds plus a chlorine chlorine bond, so 240. This is the energy needed to break the bonds. So they've made it really easy for us by breaking it down into simple steps. It can, however, come directly also in a one single 4 mark question. So this is the answer. 2490, the energy needed to break bonds. Use your answer in step 1 and the energy change for the reaction to determine the energy release when bonds are formed. Okay, so the energy release when the bonds are formed. So the enthalpy change is energy in minus energy out, or maybe you can say energy absorbed minus the energy released. So we know the enthalpy change, which is minus 180, and the energy absorbed in bond breaking is this, and the energy released in bond formation is maybe X. Now X will be 2490 plus 180. So X will be 2670. Use your answer in step 2 and bond energy values to determine the energy of a carbon chlorine bond. So we know the total energy which is released in bond formation, which is this, and we know the energy for this bond, all these four bonds except this. So from this we can calculate the energy of a carbon chlorine bond. So what we have over here is energy out, which is the X we calculated in step 2. That will be equal to the total bond energies over here in the product side. So we have four CH bonds, again for 410 plus two Cl bonds. Now we can write this as Y. So E out we calculated. Let's just move this. Yeah, so now the energy out was 2670 equals to 4 times 410 will be 1640 plus 2y. Y will be 2670 minus 1640 over 2. So 2670 minus 1640 over 2. This will be 515, which will be our final answer, the bond energy of a of a carbon chlorine bond. So let's just give it another look. So, okay. So we missed one bond. We missed this carbon-carbon single bond. Okay. So the total energy which was required to break the bonds was 2670 over here. Now, what we needed was the bond energies, the individual bond energies on the product sides, because the energy released over here, the energy released over here, which is this, is the total of this. The sum of all these energies is the energy released while these bonds formed. So the total brings it to 2670 will be equal to the 410s, sorry for the confusion, plus the carbon-carbon single bond, which is 350, and plus 2y, which is now the Cl-Cl bond again. So 2y will be 2670 minus 1990 if we solve it and divide it by 2. So this will come out, y will be 340. So sorry for the confusion. This is the final working. Now let's go over it once again. First, they told us to calculate the energy needed to break bonds, which is all the energy over on this side. Because over here bonds are broken, and over here the bonds are formed. Over here the bond for the bond breaking energy is absorbed, and over here after the bonds are formed, energy is released. So the total the when we minus these two, we get the enthalpy change, the total energy change for this reaction, which is given to us already. So calculate the energy needed to break bonds, 2490 total, because we added all these bonds from the given bond energies. Now use your answer in step one and the energy change for the reaction to determine the energy released when bonds are formed. So the total energy over on this side, which is released, we have to find that out. So for that, what we did was we wrote the equation, the enthalpy change is energy in minus energy out, and we just formed an equation and formed variable x and solved it. So the enthalpy change was given and energy in we calculated over here. So for that we calculated the total energy released from all these bonds. Now when we knew the total energy released, we also knew these bonds except for the carbon chlorine bonds. So we just deducted the carbon chlorine bonds, and because there were two, we divided by two to get one single carbon chlorine bond. Now maybe this is the last question. Yes, so the names of four esters are listed. So the names are given. Esters are a family of organic compounds with similar chemical properties. They can be represented by the formula CnH2nO2. Okay. State the name given to a family of organic compounds with similar chemical properties. So this is, we know, homologous series. Homologous series. For example, alkenes, which have which have the same functional group and similar chemical properties. Next, explain why members of a family of organic compounds have similar chemical properties. So we just discussed that the homologous series in a homologous series, all the members have the same functional group, which is the reason for their similar chemical properties. They have the same functional group, as the name itself suggests, functional group. This is what functions in the compound. State the name given to a formula such as CnH2nO2. This is the general formula. For example, in alkanes, it is CnH2n plus 2. In alkenes, it is CnH2n only. Determine the value of N in butyl propanoate. In butyl propanoate, we have butyl means four carbons from the alcohol, and propanoate means three carbons from the acid. So 4 plus 3, 7. So total 7 carbons are present. So Cn should be 7. N is 7. All four of the esters in the list are liquids at room temperature. Name the technique used to separate ethyl propanoate from a mixture of the four esters. So the different liquids are separated according to the different boiling points. So that is fractional distillation. When different soluble liquids are separated Not necessarily soluble. When different liquids are together in a mixture, to separate them according to the different boiling points, we use fractional distillation. All four esters can be made by reacting different alcohols with the same substance. Name this substance and draw its structure. Show all of the atoms and all of the bonds. Okay, so all four esters, they might be something common. Yes, the acid part is always propanoid, 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 which means that it is propanoic acid. Propanoic acid, the structure for which is we have three carbons, all the bonds, so and the functional group COOH. Name the alcohol used to make methyl propanoid. Some propanoid is the acid part, methyl is the alcohol part, which will be methanol. Next, other esters not in the list have the same molecular formula as propyl propanoate but different structures. State the term used to describe substances with the same molecular formula but different structures. Isomers. This is the definition which can come also. They might ask you what are isomers. So this is the exact textbook definition, that they have the substances having same molecular formula but different structures or structural formula. Name two esters with the same molecular formula as propyl propanoate. So this basically means they should have the same number of carbon, hydrogen, and oxygens, and that will be obviously same oxygen. The number of oxygen will always be two in any ester, basic ester at your level. So we need to have seven carbon atoms or six carbon atoms, three from here, three from here. So and the yeah, so six carbon atoms. So if we use an alcohol having two carbons and an acid having four carbons, we can fulfill the requirement of six carbon atoms. And if we use if we use an alcohol having four carbons and an acid having two carbons, then again we can fulfill the requirement. So two carbon alcohol will be ethyl and the four carbon acid will be butanoate, and the four carbon alcohol again will be butyl from butanol, and the acid will be ethanoate. Polyesters can be made from the two different molecules shown. Complete the diagram to show a section of the polyester made from these two molecules. So an ester bond is formed when the acid group, the OH, and the H from the alcohol group are eliminated to form a water molecule, and these two directly join, and the bond of this salt is formed. So we have to take care to have the correct functional group on the correct carbon chain. So the shaded one should have the acid chain, and the non-unshaded one should have the alcohol one. So this O and this H will be eliminated, and this is used to show the continuation of the bond. Next, on the other side also, we have another O, and this H will be gone. So first, let's draw the monomer of this side, and this will be joined like this. Let's just draw it like this first. If this is the bond, this is the oxygen, this will be the carbon, the double bond, the chain. The again the carbon, the double bond, the oxygen, the chain, unshaded one, again the oxygen. So this is how it goes. Now you'll better be able to understand this. Oxygen, carbon, double bond, again the chain, again the carbon, the oxygen. Just goes on and on, and it repeats. Just worry about the first unit and then copy your first unit over to the other side. Name the type of polymerization that takes place when this polymer forms. So water is being formed. So this is condensation. Name a polyester. So this should be pterylene, but it is no longer in your syllabus. while the polyester in your syllabus now is PET. So, and we have another thing which is called nylon, which is a polyamide. So this is it. The last question completed. Jazakallahu khaira.